So in the last videos, we started how we can able to work with single linked list. So as a part of that single linked list data structure, we have seen how to create node class and how to print the list. Next, how to insert a new node at the very beginning of the list and how to insert a new node at the last location and how to insert the node at a specified location we have seen very clearly in the last sessions. Sir, even how many nodes are present in the linked list? Next, and after that, middle element present in the linked list. Then search operation, delete at first, delete at last. I explained very clearly. So in today's session, we will talk about delete. Okay, so delete from given location. So they are going to give a specific location. We have to delete from that location. We will see code for that. So which function we have to invoke? I'm going to take delete from given location. Sir, I'm going to take def keyword. So delete at a location, I'm going to provide a head pointer. Okay, I'm going to provide a head pointer. So next, and after that, one second. So delete at a location, I'm going to provide one head pointer. Next, and after that, the location from which you have to delete. So suppose if your head pointer is equal to none, then what is the meaning? Simply I am going to return none, because if there is no element in the linked list, how we can able to delete? That's why I am going to return none. And if location is equal to 0, can I say it is something like delete at first? In such cases, which value we have to return? Head dot next we are going to return. So otherwise, I am declaring I is equal to 0 and the current node is pointing to head. So we have to move up to the location where we need to delete. Okay. So as of now, consider I am taking a linked list. So like this, this is nothing but the first element in the linked list with the content 11, and consider this is nothing but the second node present in the single linked list with content 22, and this is nothing but the third node with content something like 77, and this is nothing but the fourth node what we have with the content 88. Okay, and the last node with the content 99. Assume these are nothing but the elements which are present here. So this is nothing but which node? Head node. So assume the location which I have given is 0 1 2 3. I want to delete the element which is available at third location. For that I am taking I is equal to, okay, for that I am taking I is equal to initially 0 and the current is nothing but which node? Head node. So I will write a loop to make this current node pointing to up to double seven. How you can able to point? While I less than location minus 1, at the same time, if a current node is not equal to none, then what we have to do? Current is equal to current dot next I am taking, and I is equal to I plus 1. Now you can able to see. So here, what is the initial value of I? 0. Is 0 is less than location minus 1? Yes, condition true. Is current is not equal to none? Is the current node is not equal to none? Yes, right. Then what will happen? Your current will become current tends to next. Then I will become I plus 1. Now onwards I will become 1. Again it will check for the condition. Is I is less than location? Yes, condition true. Is current is not equal to none? Yes. Your current will become current dot next. I will become I plus 1. So now your I value is 2. So is 2 is less than or equal to 2 condition is false. That means we are coming out from the loop. So we came to the location where we need to delete. Our target is what? 888 only, 88 only, right? This node we have to delete. So I came from that location. Then what we have to do is, so if that current dot, if that current dot next is not equal to none, so that means is the next node is not equal to none. So 77 is the current node, its next node is 88, which is not equal to none. Then I am taking, so current dot next is equal to none. Okay, but it is not equal to, it is equal to. That means after 77, so I mean after 88, if next node is not there, this is the last node, means directly we can able to remove. Okay, if current dot next 77 next node is not there, then current node next field will become none. Like this I am taking. Generally it won't happen. So otherwise what I am doing here, see, you are right. So otherwise I am going to take current dot next field will become, so current dot next, like this I am taking, and at last I am going to take a head and see what will happen. Sir, here current dot next 77 is the current node, right? Its next field will become current dot next 77 next field is 88. 88 next field is 99. So this node next field is pointing to 99. Like this I am going to attach, so that by default what will happen, this node is going to be removed. Like this we have. Okay, so this is nothing but how it is going to work. So if I want to execute this, first we have to create the nodes, because in the previous session whatever we executed that will be lost. Let us take initially head is equal to none, and I am creating, so insert at, okay, insert at last of, so double one. But if you want to execute this, first we have to execute insert at last. Better I will do one thing, so run all, like this I am going to give, so that all these scripts will be run. Okay, now so insert at last, we are going to give, so 11 as the data. Okay, and head is nothing but the starting pointer. So after that again I am going to take head is equal to insert at last, which element I am going to insert? 22. Insert at last of 77. So insert at last of 88. So insert at last of 99. These are the elements what we have. After that I am going to call print list of head. If you run the program, you can see 11, 22, 77, 88, 77. Like this we are getting. Now I am going to take head is equal to, so delete. What is the function name that we have? Delete at location. So delete at location of, I am giving head, from which location we are trying to delete? 3. So after that if you call print list of head, so what will happen? It is going to print 11, 22, 77, 88 got deleted. This is the way how to delete the element from the given location. So are you clear with this delete element at a specific location? Please confirm.
Yes, sir.
Yes, please confirm everyone.
Yes, sir.
Right. So now I don't have location. Okay. So these examples, whatever I covered, so is for what? For deleting from the first position, deleting from the last position, deleting from the given location. In these 3 cases, we are talking about only the position. Now I am going to take, so delete the element. I want to delete the element. So how you can able to do that? So I am taking delete element. So I am defining a function called delete element, where I will give head and then data. So now in this example, we are going to delete the data whatever we have given. In this case, the functionalities are common. If your head value is equal to none, I am going to return none. And if head dot data is equal to the data which you want to delete, then simply I am going to return head dot next. That means what? If you are trying to delete a node which is available at the first location, how you can able to check that? So if head dot data is equal to the data which you want to delete, that means that node is available at first location. We note the code, right? Simply we are going to return head dot next. So automatically it is going to remove. Otherwise what we are doing, I am taking current is equal to head. So under current is not equal to none. That means if the current node is not equal to none, then I am taking current node dot data is equal to data, means immediately we will come out from the break. Sir, till that what we are doing, I am taking previous is equal to current, and current is equal to, so current dot next. Like this I am taking two instructions to move to the element. For understanding this, let us take one simple example. Consider I have a linked list. So 10 is nothing but the first element in the linked list. So 20 is nothing but the second element which we have. Okay. So 30 is nothing but the third element which we have. And 40 is nothing but the next element what we have. Like this we have continuous data is there. Now the data which I want to delete is nothing but last field is pointing to none, and the name of this node is nothing but what? Head. So I want to delete the element. Sir, which element I want to delete? Maybe consider 30 I want to delete. So the data which I have given is nothing but what? 30. So and trace this loop and see what will happen. Is head is equal to none? No. Is head dot data is equal to data? No. So current node will become head, sir. Is current is not equal to none? No. Current dot data is equal to data? No. Previous field will become current. This will become previous, and current will become current dot next. And check, is current is not equal to none? Yes. Current dot data is equal to data? No. Then previous field will become current. So then current will become current dot next. Is current is not equal to none? Yes. Current dot data is equal to data? Yes. Then come out from this loop. Sir, now you can see, if I want to delete this, we need to combine these two. For that I have given a name for this node. What is the name of this node? Previous node. And this node is nothing but a current node. Now see how I am going to take the links. So if the current node is not equal to none, yes, current node is not equal to none, previous dot next field will become, so current dot next, and at last we are going to return head. So previous dot next means what? Sir, this is the previous, right? It's a next field I am attaching to current dot next. Current dot next. Like this we are going to attach, so that by default this link will be deleted. This node will be deleted. This is nothing but what we have. Sir, to demonstrate this, I am going to take this example, like head is equal to, sir, same example I want to draw 10, 20, so 30, 40. Okay, and I am taking 50. If you print the list, it is going to print like this. Now head is equal to, I am going to take which function we implemented? Delete element, right? So first let us print the list, print list of head. After that, so head is equal to delete element of which data we want to delete? Sir, 30 I want to delete. After that I am going to print list of head. Now run the code and see what will happen. Delete, sir, delete element. In addition to this, we have to give that head pointer also. That is very, very important. Now you can see the node 30 got deleted from this. Okay, sir, everyone please confirm how to delete the element. Is it clear?
Yes, sir.
Yes, please confirm everyone. Is it clear?
Yes, sir.
Right. Sir, someone asked yesterday how you can able to sort the given data in the linked list. Highly impossible. but we have one option is there. What is that option is, sir, I explained the delete element. We have sorted insertion is there. That means what, at the time of inserting we can perform sorting and then we can insert. Okay, and see how it is going to work. Sorted insertion in ascending order. Okay, I'm going to define a function like sorted insertion in ascending order, where I'm going to give head and then data. So first of all, we are going to create a new node with the given data. Okay, first we are going to create a new node with the given data. So let me take a parallel examples. Sir, first node I'm creating. So what is that node? For example, let us consider I'm creating a node with the content 5. So this node name is nothing but what? New node. Like this I have created. Now I'm checking, is head is equal to none. Initially we don't have any head, right? That's why return new node. That means this will become which node, sir? Head node only. Since we don't have any head node, this will become head node. Okay, up to this fine. Now second time I'm creating a new node. For example, consider the new node which I want to create is nothing but, so let us take the new node is this one. So 3 is nothing but the content. This is the new node what we have. So now is head is equal to none? No, because head is pointing to 5, which is not none. Then what will happen? I'm going to check, is the data which you want to insert, is it less than head dot data? Sir, the data which you want to insert is 3. What is the head dot data? 5. So condition is true, right? In such cases, what we are doing is new node dot next field will become head. Okay, and then we have to return new node. Sir, new node dot next field will become head. This is the new node, right? It's next field we are attaching to the head. Okay, so automatically if you return the new node, what will happen? So that will be assigned to head, right? So like this it is going to create. This is the way how you can able to add. Sir, it is something like add first. Suppose consider I want to insert a new node. This is nothing but the new node. The data is 7. Okay, and the next field is none. This is the new node. Is head is equal to none? No. The data which you want to insert is 7. Is it less than head node data? No. That means we have to compare and we need to insert. Sir, how to do that? If all these conditions are not satisfied, then actual comparison is going to start. So current is equal to head. I'm going to take a special pointer. So current, which is always pointing to the head node. So current is available at the head location. So I'm checking, is current dot next is not equal to none. So current dot next is not equal to none. And I'm going to take current dot next dot data. Is it less than the data which you want to insert? If yes, current is equal to current dot next. Now cross check here. Sir, is current next node is not equal to none? Yes, sir. Sir, is current dot next 5, is its data is less than 7? Yes, condition true. Then what will happen? Current will become current dot next. Sir, is current next node is not equal to none? No, it is equal to none. That means it will come out from the while. Then what I am doing, your new node is there, right? Its next field will become current dot next. Sir, what is the current dot next? None, right? So that means this new node will be attached here. So after this, what we are doing is, sir, we are going to return. Okay, we are going to return. Sorry, here we have to take one more thing. So current dot next field will become what? New node. And at last we are going to return head. So what is the current node? 5. Its next field will become which one? New node. That's all. We are going to return this head. Like this we have. Sir, don't worry. I will take one more test case. You will get more clarity. Assume I want to insert a node called 6. We know where it will be inserted. This is nothing but none. Name of this node is new. Is head is equal to none? No. The data which you want to insert 6, is it less than head dot data? No. Current is equal to head. This will become current. Current dot next is not equal to none. Yes. Current dot next, that is 5, its data is less than the node data. Yes. then current is equal to current dot next. Is current dot next is not equal to none? Yes. Current dot next data 7, is it okay, is it less than the data? No. That means it will come out from this. New node dot next field will become current dot next. Current dot next is 7. New node next field will become 7. And the current dot next field will become new node. Like this we are going to attach. Okay. So if you want to insert sorted insertion, slowly we are going to compare. Okay, slowly we are going to compare with each and every element. Whenever its position is came, directly we are going to insert. This is nothing but sorted insertion in ascending order. Okay, so don't worry, I will execute this code and I will show you. So as of now, consider head is equal to none. There is no elements in the list. Now head is equal to, I am taking, so how to call this a function? Sorted. What is the function name that we have taken? So sorted insertion of ascending order. I am taking head comma. First I will try to insert 5. So after that I am taking 2. After that I am taking 4. So after that I am taking 1. After that I am taking 3. You can see in which order I added. Okay, in which order we added. Sir, in the same order is it going to come? Never. So in the ascending order it is going to be added. So print list of head I am taking. You can see, sir, in which order we added. So something different, but in which order we got? In the ascending order we got. This is the way how to perform sorted insertion in ascending order. Okay, sir, is this sorted insertion in ascending order, is the concept is clear for you people, friends? Please confirm.
Yes, sir. Sir, can we reverse the linked list?
Sir, yeah, we can do. We can do. I will explain. I think we have a code for that. Sir, please confirm everyone clear.
Yes, sir.
And sir, one more question is that can we display a linked list from the end? Or means the same question that is I want to reverse a linked list and to print an element in a
Using
from
recursion method we can do, because in the recursion we covered, right? Tail recursion, non-tail recursion, two types of there, right?
yes, sir.
I use a tail recursion, you are going to get in the forward direction. If you take non-tail recursion, we will get in the reverse direction.
That is nothing but backtracking.
Got it right? Just it will store the data in the stack. Okay. So if you are calling based on that, the order which we are taking, in that it is going to print. If you take non-tail recursion, the data won't be printed, right? Every time it will push the data in the stack. So automatically it is going to return in the reverse order. Got it?
Got it, sir. And sir, one more question is, can we convert this data structure into another data structure like a list or
As of now, it is not possible, because we are implementing manually, right? Suppose if you want to do that, you can go for this toString method is there in Java, like that underscore underscore str method is there in Python. Okay, you can represent in the form of list. I mean, you can represent the list in the form of string and you can return that. If you typecast to list, maybe a chances. Okay,
okay, sir.
right. So once if you know how to sort the data in ascending order, sorting the data in descending order is very easy. So how to sort the data in descending order? In the place of less than, you have to take greater than. In the place of less than, you have to take greater than. Except that remaining things are same. Now let us take this example as it is. I am taking sorted insertion in descending order. Now you can see automatically the data is coming in descending. This is the way sorted insertion in ascending order. Okay, and sorted insertion in descending order. Are you clear with this terminology? Please confirm everyone.
Yes, sir.
Right. Right. So there is one more method is there. I mean, one more task here. I want to delete. Okay. I want to delete duplicates. I want to delete duplicates from sorted list. Please make sure if you want to delete a duplicate, compulsory the list must be in sorting order. Then it will become very easy. Why? Because so we can check the next node, right? So like that we can able to do. Anyway, I will show you, then only you will get clarity. But before doing this, so I'm going to take head is equal to something like initially none, and I'm calling a function called sorted insertion in ascending order. Better I will take as it is. So in this, I'm trying to insert the data called 10. Okay, next and after that 20, next and after that 30, next and after that again 20. So next I'm taking 40. Okay, next I'm taking again 20. So next I'm going to take so 50. Again I'm going to take 20. Like this, we have a list is there. In this, repetitive elements are there, right? I want to delete. So for that, I am writing the code. Delete duplicates from the sorted list. Very simple, sir. I am going to take, let me define the function def. So remove duplicates. Better to write the function name as remove duplicates. So it is going to take only head pointer, and I am going to take current is equal to head. How many elements are there here? Let us draw those elements. The first object what we have is a 10. Okay, so next object is also 10. So next object is a one second. Yeah, first object is a 10. So second object is a 20. Okay, so third object is also 20. So next object is also 20. 1, 2, 3, 4 20s are there. So next object is also 20. Okay, next object is a 30. Next object is a 40. Next object is 50. Like this we have. From this, I want to delete duplicates. So initially, I am going to take current node will become head. This is nothing but the head as of now. So after this, I am going to check is current node is not equal to none. Yes, right here current node is not equal to none, and current dot next is also not equal to none. Yes, current node is a 10, next node is a 20, both are not equal. So I am going to check is current node data is equal to, so current node next dot data, Sir, current node data is a 10. Is its next node data is a 10? No. We will write code later. Otherwise, what we are doing, we are going to take a current is equal to current dot next. So in this example, current is equal to current dot next. Again, is current is not equal to none? Yes. Current dot next is not equal to none? Yes. Current dot data is what? 20. Current dot next node data is what? 20. Both are same. In such cases, I am going to write only one line code, which is nothing but a current dot next field will become. So current dot next. So current dot next field will become current dot next. That means like this we are going to get. So by default it will be removed. Now again it is going to check is current is not equal to none? Yes. Current dot next is not equal to none? Yes. Okay. So again if condition current dot data is 20, is current dot next dot data is also 20, then what will happen? Current dot next field will become current dot next. Like this it is going to move. So by default this is also gone. Now this is current node, this is the next node. Is current node is not equal to none? Yes. Current dot next is not equal to none? Yes. Current dot data 20. Is it current node next dot data? Yes. Then what will happen? So current node will become current node next dot next. That means it will be attached to 30. This link will be gone. Is current node is not equal to none? Yes. Current dot next node is not equal to none? Yes. Current dot data is 20. Current node next dot data is nothing but 30. So both are not equal. So current will become current dot next. Is current is not equal to none? Yes. Current dot next not equal to none. Is current dot data and current node next dot data is the same? No. Current will become current dot next. Is current is not equal to none? Yes. Current dot next not equal to none. Is the both are having same data? No. Then current will become current dot next. Is current is not equal to none? Yes. Current dot next dot data, it is equal to none. So it will terminate. So you can see, so at last we are going to return head pointer. Now let us call the same function. So as of now, I am going to print list of head. Now I am taking head is equal to remove duplicates from this head, and I am going to call print list of head. Now if you run the code, you can see something like remove duplicates. Now you can see. So 20 is available how many times in the original list? 40. Now only one copy will be there. Remaining copies got deleted. This is the way how you can able to remove duplicates from the given list. Any doubt up to this whatever we covered?
No, sir.
Clear, right?
Yes, sir.
Right. So this is nothing but how to remove duplicate elements present in the given list. So next operation is, sir, I want to perform copy operation. Okay. So removing duplicates got completed. Removing duplicate elements from the linked list. Sir, now what is our next operation is, I want to create another copy. Okay, I want to create another copy of linked list. Already I have a linked list is there. So now I want to create another copy. So let us see how you can able to do this operation. Okay. So first we are going to create one list and we have to implement a program. So to make another list with the same elements. Let us see how you can able to do that operation. Okay. Right. So let us see. So the first step here, what we have, I am going to define a function to perform copy list. Function name is also copy list, where we are going to give a head. First we are going to take current node is equal to, better to take CUR, current node is equal to head. We are checking is that current node is equal to none. Then we are going to return none. So means what? If there is no linked list, then what will happen? If you copy also, so the target list contains no elements, right? Like that we have. Otherwise, I am taking head node, a new name, sir. This one is not like head. It is a new name called head node. Head node is equal to, I am creating a new node with the current node data. Okay. So I am creating one more node called tail node. So with head node. With the head node, then sir current node will become current node dot next. So total how many lines of code is there here? 3 lines. For easy understanding purpose, I am taking only 4 elements. So this is nothing but the first element what we have. Let us consider 10. The next node is nothing but something like we have 20. So the next node what we have here is 30 is there. The next node what we have here is 40 is there. Like this, total how many number of elements are there? 4 elements are there. This will become which node? A head node. Like this we have. Now I want to make a copy. So first current node is equal to head. This will become current node. Is a current node is equal to none? No. We are creating another new node. What is the name of that node? Head node. As of now I am writing in capital letters. Head node. What is the data? Current node data I am taking. This is nothing but the new node. And this will become which node? Tail node. So Tn is also same thing. Now current node will become current node dot next. So we have to repeat this process, right? That's why I'm going to take a while loop. Is a current node is not equal to none? Yes, current node is 20, which is not equal to none. Now I'm creating a new node. So node of with the current node data. What is the current node data? 20, right? With that content, I'm going to create one more node. The content of the node is nothing but what? 20. Like this we have. Okay, like this we have. Now, sir, do you know here I'm going to take one more instruction. We have to link these two, right? How I am going to link? Sir, I am taking tail node. Okay, tail node dot next field will become new node. Sir, which is the tail node? This one, right? Its next field will become new node. So after that, I'm going to take. So your tail node will become new node. Sir, your tail node will become which one? New node. Like this, we are going to attach. Okay. Sir, what about next instruction? We have to take current node will become current node dot next. Sir, where current node is pointing 20. Now it is pointing to 30. We are creating another node. That name is nothing but what? New node. The content is 30. Then what will happen? Tail dot next field will become new node, and your tail will become which one? New node. Okay, your tail will become which one? New node. Like this, we are going to copy. Again, current node is equal to current node dot next. So we are going to create another new node with content 40. Okay. So is the current node is not equal to none? Yes, new node we created. So tail dot next field will become this one, and this one will become tail node. Current is equal to current dot next. That's all right. Current will become none. Automatically it is going to stop. This is the way how you can able to copy. At last, which node we have to return? Don't return head. Your newly created list is there, right? That's why we have to return head node, because head node contains the original content. To demonstrate this, I am going to take head 1 is equal to none initially, and head 1 is equal to, so insert at last I am taking, where I am passing head 1 comma, which data I am going to take? 10, and insert at 20. Sorry, insert at last of 30 I am taking. Now I am going to take print list of head 1. Now observe carefully, head 2 is equal to, I am taking copy list of head 1. So now if you print list of head 2, what will happen? So it is going to return a new list. You can see. Sir, is head 1 is a separate list. Head 2 is nothing but a copy of that list. If you are doing any modification on head 1, it won't reflect on head 2. If you are doing any modification on head 2, it won't reflect head 1. Like that we have. So is the concept is clear, friends? Please confirm.
Yes, sir.
Yes, sir.
Right. So now I want to demonstrate the last function. What we have here is reverse of linked list. I want to calculate reverse of the linked list. Let us see what will happen. I'm going to define a function for that, which is nothing but reverse, where I'm going to pass a head. So I'm taking 2 pointers. Current is equal to head and previous is equal to none. Initially current is nothing but what? Head. Previous is nothing but what? None. So while your current is not equal to none, I'm going to take a temp is equal to current dot next, and the current dot next field will become previous, and the previous field will become current, and the current field will become temp. Like this we are going to assign, and at last we will return previous. How this code is going to work, I will explain with the diagram. Sir, it is somewhat complex. Please focus. So now I will take only 3 elements in the list. This is nothing but first node what we have, and this is nothing but the second node what we have, and this is nothing but third node what we have. Like that, how many nodes are there? So 3 nodes are there here. This is nothing but which node? Head node. Head node is there, and 2, 3 like this we have. We have to reverse this linked list, but it is very hard to explain. That's why what I am going to do is, initially I am going to draw the reverse of this linked list without any links. Like this I am taking because I know the result. So without any links, for your understanding purpose, like this I am taking. Now observe friends, current is equal to head. This is the current node, right? So in this diagram, this is the current node. Both are same. Just for your understanding, I am taking. Previous field will become none. Okay. So there is one none object is there. So previous node is pointing to none as of now. Is current is not equal to none? Yes, 1 is not equal to none. Temp will become current dot next. Sir, what is the next field to current? 2. That will become temp. Now current dot next field will become previous. This is the current node. Its next field will become previous, which is nothing but none. And the previous field will become current. So what is the current node here? 1, right? That will become previous. And current is equal to temp. That means this will become what? Current node. So current node is 2 now. Again repeat, is current node is not equal to none? Yes. So 2 is not equal to none. Then temp is equal to current dot next. 3 will become temporary node. So this is the first line. Current dot next is equal to previous. 2 is the current node, right? Its next field will become what? Previous. Previous is 1. Previous field will become current. This will become previous. And the temporary field will become current. That means 3 is the current. Is current is not equal to none? Yes. Current dot next field will become previous. What is a current dot next? 3. 3 next field will become previous. Previous is equal to current. This one will become what? Current. Previous. So current is equal to temp. So which is the temporary here? Temp is current dot next, which is nothing but none. That will become current. Sir, now, sir, is the current not got? This one is gone. Sir, this one is also gone. Sir, is the current node is not equal to none? No, right? Current node is pointing to none. Immediately this while loop is going to terminate. And at last we are returning which value? Previous reference. So that will be copied to head. Automatically you can see, is the linked list got reversed or not? Yes. This is the way how you can able to reverse the linked list. Is the concept is clear for everyone? Please confirm.
Would you repeat that, please, sir? Because I am unable to get the flow.
Okay, I will take one more example. Please concentrate well. Sir, please focus clearly. So I told already it is very difficult to understand. See, I am representing 2 diagrams for this. Okay, because in the same diagram, if I delete the links, it will be very difficult for you to understand. That's why I am taking 2 diagrams. This is nothing but the first node. This is nothing but the second node what we have. And this is nothing but the third node. Totally, this is my original linked list what we have. So head is always pointing at the 10th location. My requirement is what? I need to reverse this. If you reverse, what output we are expecting? 30 should come beginning and 20 should come next and 10 should come here. This is the actual content, right? So if possible, I will do the modification in both. Please listen. So what is the first step here is current is equal to head. This one will become current. That means this one is also current. Previous is equal to none. There is no none, right? That's why explicitly I am taking previous is pointing to none. Is current is not equal to none? See here, current is not equal to none. Then temp will become current dot next. Current dot next is what? 20. That will become temp. Okay, that will become temp. Parallelly, I am giving names here also. Now current dot next field will become previous. So current dot next field, here I am modifying. Current dot next field will become what? Previous. What is the previous value? None. That means current dot next field will become none. Automatically, this link is going to be deleted. Sir, up to this, do you have any doubts?
No, sir.
Now listen. Previous is equal to current. Current node is which one? 10. That will become which node? Previous. This is the previous now. So this is the previous now. After that, so current is equal to temp. This is the temp, right? This one will become current. This one will become current. Are you clear up to this?
Yes.
Yes, sir.
Now listen, second time I am running. Is current is not equal to none. Current node is which one? 20, which is not equal to none. Temp is equal to, second time I am running this. Temp is equal to current dot next. So which is the current node? 20. Its next field will become 30. That one will become temporary. So 30 will become temporary. Then, so current dot next field will become previous. Current node is which one? 20. 20 next field will become previous. For you, better to understand, I am drawing here. Actually, current field next field is pointing to previous. That means this link. By default, so this link is going to be deleted. Okay. Now, what will happen? Sir, up to this clear?
Yes, sir.
Now, previous is equal to current. Previous is equal to current. Which is the current node? 20, right? This one will become previous. Okay. This one will become previous. Next, current is equal to temp. This one will become current. This one will become current. Now, again, is current is not equal to none? Yes. Temp will become current dot next. What is the current dot next? None. This will become temporary. This will become temporary. Now temporary is pointing to none. This is the completed. Current dot next field will become previous. Current dot next 30 next field will become previous. So 30 next field will become previous. So 30 next field here if you attach, so 30 next field will become previous. So its next field is this one. So after that, what is the next line? Previous is equal to current. Where is the current? C, right? 30, right? This will become previous. 30 will become previous. Now current is equal to temp. So where temp is pointing? None, right? That will become which one? Current. This is not current now. Now you can see all the names got erased except P. So we are returning this previous. So that if you return to which one we are copying? Head, right? So head will become 30. That links we established. So this one will become reverse. If you see logically, sir, what is the next node to 30? 20, right? What is the next node to 30? 20. What is the next node to 20? 10. What is the next node to 20? 10. Like this we have. Are you clear with this?
Yes, sir. Means, sir, whenever we are writing L dot reverse in a list, the same thing, whatever you explain, is going on behind that.
Yes, exactly. Okay. Clear up to this? Please confirm.
Yes, sir.
Right, but we need to execute this code to test. Suppose consider I am taking head is equal to none. So head is equal to, I am taking insert at last of, so 10 I am taking. For the head I am attaching 10 and I am going to add 20. I am going to add 30. I am going to add 40. I am going to add 50. Now I want to reverse this. So first I will print the list, print list of head I am taking. Then what we are going to do? So head is equal to, I am calling reverse of head I am passing. So after that, if you print the list of head, automatically the data is going to be reversed. You can see initially it was a 10, 20, 30, 40, 50. Now it is a 50, 40, 30, 20, 10. Like that each and every element is reversed. Clear up to this?
Yes, sir.
Got it? Please confirm everyone.
Yes, sir.
So this is nothing but single linked list what we have. Okay. So I request you to practice these two today. So tomorrow also we have a class at evening as usual, 6 o'clock. Okay. So not 6:15, we will have evening class at 6 p.m. So 6 p.m. to maybe I will take up to 7:30 or 8 p.m. where I'm going to cover double linked list. So with that, double linked list will be finished, and circular single linked list, circular double linked list will be covered on Monday and then Tuesday. Okay. So I'm giving time for you to refer these two classes, how we implemented single linked list. So two parts I covered. I request you to please refer that, because if you understand this single linked list, then only you can able to understand that double linked list. So I request you to please refer these videos tomorrow. Okay.
Yes, sir. And sir, one more thing. You told us that you will give the sign-ups of sorting and searching.
Yeah, I will give tomorrow. Okay.
Okay, sir.
Yeah, right. Maybe after completion of linked list, I will address that. Okay.
Okay, sir.
Right, sir.
And kindly, sir, tell the team that to upload the video till night, sir, because we have to wait up till the, means we have to wait for the next day to upload the videos.
I will instruct that team. Okay. Yeah. Sir, tomorrow we have class as usual at 6 o'clock. Okay. Right. Thank you.
Thank you, sir. Have a nice day, sir.
Thank you, sir.